Hello and welcome to 101 Code. My name is Muaz Nashawi. If you like our videos, don't forget to comment, like, and subscribe, and turn on the notifications so you can see all the new videos. In this video, we'll talk about encapsulation, which is one of the four main principles of object-oriented programming. So we're gonna see the definition of the encapsulation. We're gonna discuss the benefits of using the encapsulation principle in our object, on our project, and we finally gonna see some live example project with the code in Java. So without any further ado, let's get started. So what's encapsulation? Encapsulation is the concept of protecting the object states from direct manipulation, which will raise security issues, present unnecessary troubles, and bypass certain method operation in your project. Encapsulation deal with the object-oriented principles on the security level, while abstraction deal with the object-oriented programming on the design level. Abstraction is the second principle of object-oriented programming. It has some similarity with the encapsulation. We will have different video for the abstraction. Let's focus today on the encapsulation. So in general speaking, encapsulation is the concept of hiding your object states or your class attributes from direct manipulation. So you give your attributes inside the class, a private access modifier, for example, and you only allow the manipulation of these attributes through some public methods. Inside these methods, you may want to apply some logic. You may want to check for authorization, for example, or do any kind of logic before you either allow or prevent the manipulation of these attributes. This way, you can protect your data, and you can always present a validation for your object states. So your object will never go, for example, with bad states or bad information on. To understand this more, let's get to the code. In our example, we're gonna build a bank account app. This bank account app will be performing some operation on the client account, like deposit, withdraw, and get amount. So we're gonna build a class in Java. This class will have two attributes, account number and amount, and it will have three methods: deposit, withdraw, and get amount. As you can see, I'm using the green color here with the plus sign to indicate that the account number and the amount, the attributes, has a public access. So green color with the plus sign is a public access. And also the three methods has also a public access. This example is built without implementing the encapsulation principle. So let's see what the problem with this implementation. So let's get to IntelliJ to see what is the problem with this kind of implementation. We have here a bank account class, as we said. There's two attributes, account number and amount, and all the methods here: withdraw, deposit, and get amount. It's all public. As you can see, also the attributes is public. Let's get to the main.java, and we're gonna start here by instantiating a new instance of the bank account app. In the constructor, we need to provide the account number, the employee username, and employee password. Here I implement some logic for employee authorization. So any operation should be done by an authorized employee. So I hard-coded the username and the password, as you can see here. Now let's try to run this example. As you can see, account initialized for operation. But if I put some wrong password, for example, and I try to run it, you can see error, please check added information. So it's hard-coded here. Let's now do the first operation on this application, which is deposit. Here I'm gonna try to deposit 50 euro inside the client account. If I tried it here, successfully deposit, your amount is 250 euro. So now we have 250 euro in the account. Let's try, for example, to withdraw now 500 euro. As we said, we only have 250 euro in the account. And now we're trying to withdraw 500 euro. That's insufficient. So if we try it now, we're gonna get failed to withdraw insufficient amount. Until now, everything worked perfectly as it's planned. The problem starts here with this implementation when we come here and implement and we direct manipulate the attribute of amount, because we have public access on the amount attribute. We can here directly manipulate it. This problem here is that when we directly manipulate it, we are able to bypass the logic in the deposit method. We are also able to bypass the authentication of the employee, and we directly manipulate the attributes. Now, if we try to withdraw 500 again, we're going to be able to withdraw it, successfully withdraw. Your amount now is 4,500. As you can see, this application is not working properly. That's like an issue on it. Let's now implement the encapsulation principle to fix the issue with this implementation. Now, let's see the diagram. Now, in implementation of the encapsulation, we are changing the attributes access modifier from public to private. I'm using the red color with the minus sign to indicate that this attributes has a private access now. Let's get to IntelliJ to see that. Now, in our class, if we change the access modifiers of the attributes to private, as you can see, IntelliJ detects immediately that there's a problem with the private, because in another place someone is trying to direct manipulate an attributes. Now we're not able to perform any direct manipulation. This way, first you protect your data, and also you are making sure that nothing gonna change until you perform all the necessary logic on it and necessary authorization. So this is the benefit of using the encapsulation principle as a start in your object-oriented programming project. That's it for this video. In next video, we're gonna talk about abstraction in object-oriented programming in Java. And we're gonna describe more about object-oriented concepts. If you like our videos, don't forget to comment, like, and subscribe, and turn on the notifications so you can see all the new videos.